Hey guys, Miller here. Little intro music for you there too. I don't know if you guys like oldies, but that's Grazing in the Grass by the Friends of Distinction. If you haven't heard it before, maybe look it up, listen to it. It's a pretty good song. I'm taking this time to make a video on reviewing for Quiz 2, which we'll be having this Friday, November, what would that be? Not the 16th, 17th. And in this video, I'm going to basically do a few examples of each type of problem that I'm going to expect you to be able to do on the quiz. What will you be expected to do exactly? You'll be expected to do these things here. Graph quadratic functions in vertex form, graph quadratic functions in standard form, factor quadratic expressions, and what we did today in class, solve quadratic equations. Now, the majority of the points are really going to come from these first three things, whereas the last thing, sorry, I had to pause the video for a moment. I was interrupted, somebody at the door. Anyway, what I was saying was the first three things is where the majority of the points will be, whereas this last thing, solve quadratic equations, it'll be, there'll be some points on solving quadratic equations, but not nearly as much as these three things are going to be worth. That doesn't mean it's not important. You want to get as many points as you can, but the brunt of the points will come from these first three things. Okay, good. Yeah, it's still recording. All right, so let's go to our first example. And the instructions that you're seeing, these four things, make a TOV, graph, indicate coordinates of the vertex, all that stuff, those are the same instructions that you're going to see on the quiz. And what I'm going to do is walk you through now, going through those four things. So let's start with letter A. It says make a TOV centered at the vertex. In order for me to even make a TOV, I need to know what the vertex is, because the TOV is going to be based on the vertex. What is the vertex of this quadratic function? Well, let's do a little bit of review. And remember that a quadratic function in vertex form looks like this. The general form of a quadratic in vertex form. Remember that h is the first coordinate of the vertex, k is the second coordinate of the vertex. Now you'll notice that in the general form, there's a minus in front of the h, but in the vertex as a point, that minus is left off. What that's telling us is we have to take the opposite of whatever that number is inside. On the outside, what you see is what you get. We don't switch the sign on k. It's going to stay the same. What would the vertex be if we were given this function? The vertex would be positive 1, taking the opposite of negative 1, positive 1, and the outside number is 4. What you see is what you get. And what we want to do now, given our vertex, is make our TOV. All right, so I'm going to put the vertex right in the middle. 1, 2, 3, 1, 4. And do you remember how we get our other x values? What do? We always do the same thing. No matter what our x is, this coordinate of the vertex, we're always going to add 1 going to the right. That's going to give me 2 and then 3. And then going the other direction, we subtract 1, 0, and negative 1, right? 1 minus 1 is 0. 0 minus 1 is negative 1. Remember what I said? Pick a side is like Twix. You have to pick a side. This table has two sides to it, considering the vertex slices it in half. We have a left side and a right side. And if you're lucky to get your table to have 0 in it, that would probably be the side of the table I would want to work with. I want to point out that that may not happen, though. It just depends on what your vertex is. For instance, if our vertex would have been 8, negative 7, Well, when you add 1 to 8, you get 9 and then 10, and then going the other way to the left, you'd get 7 and 6 by subtracting 1. You don't get 0 in that table. You will not always get 0 is what I'm trying to say, but when you do, life is good because 0 is going to make things easy for us to compute. I'm going to work with the left side of the table, and what I need to do is find -1's partner, and then I need to find x equals 0's partner. To find -1's partner, I have to plug -1 into my function, what we were given, and find out how much y is. Let's make sure I can get it written right here. -1 minus 1 squared plus 4. And what we do now is follow order of operations. Order of operations is PEMDAS. Okay, parentheses come first, and I need to subtract this. -1 minus 1 is -2. All we have left inside our parentheses is a number. There's nothing left to do inside. We can now move to E in PEMDAS, exponents. -2 squared is 4. I hope you said 4. Okay, and then I can multiply this out. 2 times 4 is 8. And then 8 plus 4 is 12. We plugged in -1. We got back 12. Okay, and yes, I don't have enough graph to graph a value of y is 12, and I'm sorry for that. We'll worry about that in a little bit. Have to come up with a creative way to adjust our coordinate plane in order for this to work. On the quiz, you won't have that problem. You'll be able to graph things very easily, and I'm sorry that this came out to such a big number. Now let's do for 0. Wherever I see an x, I'm going to plug in 0. Subtract first, inside parentheses, that's going to give -1 squared. Square -1, -1 squared is +1, plus 4. Multiply, 2 times 1 is 2, 2 plus 4 is 6. We plugged in 0, we got back 6. 0 and 6 are partners. And now after all that work that we had to go through to get those two numbers, the nice thing is we get the other side of the table for free. The first and the last will match. The second will match the second to last, which means 6 is going to get paired with 2. Alrighty then, we have our table of values. Now we can actually graph the thing. And let's see, -1, 12. -1, we're just going to say it's all the way up here at the tippy top. Let me use a different color, by the way. Okay, there we go. And 0, 6, 0, 6. And what else do we have? We have 1 for x, 4 for y. And then 2, 6, 2, 6, and 3, 12, way up at the top. Okay, and then what you would do is connect those 5 points to make a nice, smooth, U-shaped curve. I'll try to do it, but I'm not very good at using this smart pen yet. I'm still new to it. Okay. All right, and there you have it. There's our graph. Now, we have A done, we have B done. We actually have C done also. When we found the vertex, we also answered part C. So the vertex is 1, 4. Somebody's at the door. I got to pause the video again. I'm sorry. Hang on. Well, aren't I Mr. Popular? Sorry about that interruption. So our vertex is, which we already found it, 1, 4. And then letter D, find the equation for the axis of symmetry. All right, that's going to be really easy, right? Whatever the first coordinate of the vertex is, that is the number for the axis of symmetry, but it says write it as an equation. The axis of symmetries for our functions, our quadratics, will always require us to write x first equals the first coordinate of the vertex, because this would be the equation of a line going north and south, and it would split our vertex right down the center. Okay, that's it. That takes care of our first example. Let's move on to our next example, and let's say that you were asked to graph something like this. Notice that the steps are the same. Make a TOV centered at the vertex, graph the function, give the coordinates of the vertex, indicate the equation for the axis of symmetry. Now, this one is not in vertex form, is it? It's in the other form, standard form. Standard form looks like this. You have the exponents going from the largest, which is 2, then to the next largest, 1, and then to the next largest, no x's, x to the 0. In order to find the vertex, we have to first determine what the vertex is. And unfortunately, if we're given a function in standard form, a quadratic function in standard form, we have to find the vertex first. And to do that, we use this handy-dandy formula. It's good to have this in your back pocket. And to do that, we would need to know what a and b are. What number is in front of our x squared? That's -2. So a is -2. What number is in front of our regular x? Okay, 4. That's our b value. So you see, I'm just matching things up. A is in front of x squared, which is -2. B is next to the regular x, which is +4. We're going to plug these two numbers, -2 and 4, into our formula and simplify and see how much our x is. Okay, so this is going to be -4 over -4, since 2 times -2 is 2. And we get x equals 1. So the first coordinate of our vertex is +1. What do we have to do next? We need to find 1's partner. How do we find y's partner? We use this function that they gave us, and we plug 1 in to find 1's partner. All right, if you want to, pause the video, crunch those numbers, and see what the function spits out, and then resume the video and see if you get the same thing I got. All right, let's work through it together and see if your work matches what I'm about to do. I square 1, that gives me 1. -2 times 1 is -2. 4 times 1 is +4. If I combine all of this together, I get -2 plus 4 plus 5, so I get y is 7. All right, what are the coordinates of our vertex? We can actually answer part C right now. Answer that part of the question. Our vertex is what? The first coordinate is 1. Second coordinate is, whoops, not 4, you fool. I don't know why I thought it was 4. Just wrote 7. All right, 1, 7 is our vertex. Now we can do our table of values, right? We want to do our table of values with the vertex smack dab in the middle. put our vertex. I'm just a hot mess, aren't I? I think I'm hungry. That's why I need to eat something. 1, 7. All right. Now, to get our other values, our x values, we add 1. Going to the right, starting at 1, we add 1, 2, 3. Going to the left, we subtract 1, 0, subtract 1 again. 1 minus 1 is 0. 0 minus 1 is negative 1. And basically the same steps we did on the last problem, we're going to do those same steps here. We're going to choose the side of the table to work with, plug those numbers in, and get our table, then graph. So let's do the harder one first. We have to plug in negative 1 and see how much the function spits out. Wherever I see an x, I'm plugging in negative 1. Negative 1 squared, how much is that? Uno, 1. Okay, I am sorry, that really is a pathetic negative 1. It looks like a sideways T. I apologize. Negative 2 times 1, negative 2. 4 times negative 1, negative 4. That. Negative 2 minus 4 is negative 6, and then negative 6 plus 5 would be, big finish, negative 1. Now, look what happened. We plugged in negative 1. What did the function spit out? Negative 1. Negative 1 is also paired with negative 1. Now, for 0, I was going to go very fast, because anything that has an x in it is going to drop out. But let me fill these x's in with zeros first, and then maybe we can see why that's going to happen. 0 squared is 0. Negative 2 times 0 is still 0. 4 times 0 is 0. 2 at 5. 0 plus 0 plus 5. It's 5. We plugged in 0, it's going to get paired with 5. Okay, now for the fun part. Finish the table and graph. First number is going to match the last. The second number is going to match the second to last, which means 2 is going to get paired with 5. We can now plot these 5 points on our coordinate plane. Negative 1, and then we'll connect. I'm doing it again. Oh, that looks like a heart I made. Look at that. I didn't even intend to do that. It looks like a heart. All right, negative 1, negative 1. 0, 5, 1, 7. And then we had 2, 5. And then 3, negative 1. Here are the 5 points from our table, and what we want to do now is connect these points, making a nice U-shaped curve. Okay, you know, connect them as best as you can. Hopefully you do a better job at connecting than I'm doing with this smart pen. All right, that's B. C we already answered. Vertex was 1, 7. And then the last thing is to indicate the axis of symmetry, the equation. The first coordinate of our vertex is 1. Our axis of symmetry, its equation is going to be x equals 1. All right, good job. This problem's done. Let's move on to our next example for our quiz review. And what is this saying? Whoops, didn't mean to do that. Okay, these say factor completely. Let's take a look at A. We have x squared plus 9x plus 8. And this one is a naked quadratic. I call it naked because the number in front of x squared is 1, but we don't write 1, which makes our x squared bare, naked. And what we want to do now is just set up our thing here to find out what numbers make this magic happen. I'm sorry, I'm a little distracted. There's some noise going out in the hallway, like someone's trying to bust into their locker or something, or break into somebody else's. I don't know what's going on out there. Okay, what two numbers multiply to 8 but also add to 9? If you said 8 and 1, good job. That is correct. 8 times 1 is 8. 8 plus 1 is 9. Okay, I don't see anybody out in the hall, so I guess they figured out whatever the problem is. 8 and 1. 8 times 1. 8, 1, 8, 1. Okay, our x squared is going to break up as x and x. Each parenthesis gets its own x. So think of x squared as being two people who are married. They get a divorce, now they're living in separate apartments or separate houses. Hey, they're literally x's. And now, oh my god, that's such a bad joke. My wife would be calling me a dork right now. In these spaces right here, I drop down what? Positive 8, positive 1. And that's it. This is factored. Now, we don't want to take this any further. I know that today I showed you guys how to solve quadratic equations, but you have to keep in mind this is not an equation. There's no equal sign in there. This is just an expression, and we don't want to end up solving these. We stop here, it's factored, it's done, perfect. Let's take a look at number B, letter B. And let me see, plus, no, it's minus. It's minus. Minus, okay. Minus 11w plus 10. And we're asked to factor this. This one is not naked, is it? Because there's a 3 standing right there in front of us, which means we have to multiply front end times back end first. 3 times 10 is 30. And I need to find two numbers that multiply to 30, but those same two numbers have to add to what's in the middle. And what's in the middle? Negative 11. What two numbers multiply to 30, but also add to negative 11? If you're still stressing about that, I don't know what the numbers are, I can't figure this out, what you can do is fall back on using these t-tables, t-charts, and think of all the ways to multiply to get 30. 1 and 30, 2 and 15, 3 and 10, 4 is not going to work, 5 and 6, 7, 8, 9, none of those work. 10 we already have in the chart, so that means this is done. Now, those 4 pairs, one of them should somehow give us negative 11. You might have to add negatives to one or both of the numbers, but we should be able to get to negative 11 using one of these pairs. 1 and 30, they're so far apart. No matter what you do, you're never going to get that to negative 11. 2 and 15, that's garbage. 3 and 10, that's garbage. 6 and 5, looks like it should work. 6 plus 5 is 11. So those are the numbers that we want to work with, and maybe add negatives to them. We'll worry about that in just a moment. Let me add 6 and 5 here. 6 and 5. All right, now, I don't know why I'm switching colors. I still need the negatives to add. 6 times 5 is 30. 6 plus 5 is not negative 11. It's positive 11. How do we remedy that? We're going to put negatives on the 6 and the 5. And here's a helpful trick. If the back end is positive, the sign in the middle tells you what the sign of your two numbers are going to be. Back end is positive, look to the middle has a negative. That means these two numbers have to be negative also. All right, now what time is it? Snack time? No. Nap time? No. Potty time? No. It is table time. I don't know, maybe you guys are watching this as you're going to the bathroom. I don't know. Maybe it is potty time. All right. Remember, first piece, box. Last piece, last box. And then along our diagonal, these two empty squares, we write these two numbers in. We drop them down, and we glue the variable to it. Oh, sorry, microphone, wireless mic is slipping a little bit. Sorry, I had to adjust it there. All right, now, let's say that you don't know how to factor these GCFs out like we've been doing in class. That's okay. What I would do before you even start trying to worry about your GCFs is make these T-charts for each one of your numbers that's inside the table. We've got 3, we've got -6, we've got 5. Pardon me, ignore the negative. Let's just keep everything positive, make it easy. In fact, I'm going to erase that. This is not going to be one of my best videos. I'm hungry, I'm tired, I want to go home. Okay, and 10. So let's think of all the ways to multiply to get 3 using whole numbers. And that's it. For 6, 1 and 6. 3. Another ways using whole numbers to get 6, 1 and 5. That's it. 5's prime, so those are the only factors of 5, 1 in itself. And then for 10, 1 and 10, and 2 and 5. The GCF, our first row, let's just worry about 3 and 6 for the moment. Looking at our T charts for 3 and 6, here's our T chart for 3, here's our T chart for 6. What's the biggest number that's the same in both charts? 3, right? The GCF of our first row is 3. To determine how many W's to take out, remember we go with the smaller exponent. 2 W's here, because it's W squared, 1 factor of W there, because it's W to the first, and the smaller one wins. We can take out a W. Let's take a look at our bottom row. What's the GCF of 5 and 10? Looking at our T charts here, what's the number that's the same in both? That's the biggest. 5. Right? 5. Now let's worry about the sign. The sign closest to where we're factoring carries. This first box has a minus, which means we need to attach a minus to this GCF. All right, we're getting there. We're getting there, almost done. What's the GCF of our first column? Let's look at our T charts, 3 and 5. And what's the number that's the biggest in both that matches? 1, right? Use a triangle to distinguish from our columns and rows. 1, and again we can take out a single W because the smaller exponent wins. And lastly, what's the GCF of our last column here? 6 and 10. The biggest number that's the same in both for 6 and 10 is 2, right? Okay, write my 2. And then to determine the sign, I take the sign of the box closest to where I'm factoring. That would be a -2. Now, what does that tell us? I mean, what is that exactly showing us? Pulling this stuff out, what it's giving us is the factor of, well, I should say factors. There's 2 factors, sorry. The factors of this quadratic expression. Our final answer is, got to find space to write it. How about here? 3W minus 5 times W minus 2. And that's it. We factored it. We are good to go. We have 2 more problems to get through for our review. And the next 2 problems. I promise I'll try to pick up the pace a little bit. I won't be as detailed with my explanation because, well, I don't want you guys to fall asleep at the computer. And it seems like I spent some good amount of time on the last one explaining how to factor the quadratics, and I think that's I don't want to overkill by discussing every single thing in detail. We'll go a little bit faster on this last 2 problems. All right, letter A, solve this thing. Notice that it's set equal to 0, and this should have equal 0 on the second one. Sorry. All right. Solving quadratics by factoring, we have to have 0 on one side of the equal sign. Fortunately, in both of these, we have that. What we need to do now is factor the left-hand side, and you're going to factor it just as you would if this equals 0 wasn't even there. We need 2 numbers that multiply to -2, but those same 2 numbers have to add to -1. What 2 numbers make that happen? How about -2 and +1? I think that works, right? Let's check. -2 times 1 is -2. That matches the right side. -2 plus 1 is -1. That matches the right side. These are, in fact, the numbers that make that magic happen. All right, we're going to break up our b squared as b and b. And we're going to drop down these 2 numbers that made that beautiful magic happen. b minus 2, b +1, b plus 1. Now, if we stop there, we are in trouble because that did not solve the equation. All you did was factored it. We have to set each piece equal to 0. And find out how much b is. b minus 2 equals 0. b plus 1 equals 0. Add 2 to both sides, right, to get b by itself. One solution is b equals 2. Sorry, b equals 2. And here we can subtract 1 from both sides, and we're going to get b equals -1. There you have it. There's our 2 solutions to our equation. Let's take a look at b. And how am I going to take a look at it? I've moved it, so I need to, I think I can scroll up. Okay, 4c squared minus 12c, 4c minus 12c minus 5 equals 0. Alright, and I know I'm going to need a heck of a lot more space than this, so let's bring this back up. Now, this one is not naked, is it? It's dressed. The first thing we're going to have to do is multiply front end times back end. 4 times -5 is -20. And what I have to do now is think of 2 numbers that multiply to -20, but those same 2 numbers have to add to -12. And I'm starting to panic a little bit because I don't think that's even going to work. So let's switch this up. Oh my God, this is terrible. Oh my God. I should just start over. But I'm not going to. I'm sorry. I'm not going to start over. Just have to tweak it a little bit and then do better on the next video. I'm sorry, guys. I whipped these examples up quickly after the faculty meeting that I had today. Went to the faculty meeting. It was about an hour, and then I immediately came back down here to the classroom to quickly try to make a review video for you. I wasn't even going to do a review video, but at the last minute, you know, I was like, yeah, let me help them out a little bit. Let's make them a review video. So I am sorry if it seems like I'm kind of scatterbrained. Let's review. The next video I do, I promise, I'll think through it a little bit better. All right, enough jibber jabber. Shut up and let's work it out, right? Yeah, good idea. We need 2 numbers that multiply to +20, but those same 2 numbers have to add to what's in the middle, -12. What two numbers make that happen? How about -10, -2? Yeah, -10 times -2 is +20. -10 plus -2 is -12. That's looking good. And what we need to do now is do our little table thing, right? It's table time. So, and I am going to speed up a bit. First box, first piece, 4c squared. Last box, last piece. The last piece on the left side is 5. And then in these two spots, we drop down the numbers that we found to make the magic happen. -10, -2, and then to each of these numbers, I glue the variable to it, a c. All right, I'm not going to do the t charts this time for these 4 numbers, but if you need to, you can pause the video, quickly do your t charts, and then factor out the GCFs and see if you get the same as me. That divides we can take a single c. The GCF of 2 and 5 is 1. The sign closest to us carries, that'll actually be -1. GCF of 4 and 2, Shazam, is 2. Take out a c. GCF of 10 and 5 is 5. The sign closest to us carries, that'll be -5, which means our quadratic factors as 2c minus 1 times 2c minus 5. That's what we're going to drop down in our parentheses. Now we're going to set each piece equal to 0. We'll set this piece equal to 0 and set that piece equal to 0 and solve each baby equation for c. C minus 5 equals 0. So we're going to add 1 to both sides. And where's my... I have no extend button anymore, do I? Hey, where are you? Maybe I can still scroll down a little bit. That's why. Okay. Divide both sides by 2. So c is a half. That's one solution. This equation will add 5 to both sides. How do we get c by itself now? Divide both sides by 2. So our other solution is 5 over 2. Alright guys, that's it. I hope this video was somewhat helpful. Again, sorry about the mistakes. I'll do a better job preparing a review in the next video I get, or if I get the itch to do a video, I'll make sure to plan it out a little bit better. My apologies. Anyway, I hope this is at least somewhat helpful, and I will see you guys when I see ya. And if you have any questions, feel free to email me. I'll be more than happy to help. Stay after school. I'm here almost every day, and I'm more than willing to help. All right, that's it, guys. Take it easy. And to close out the video, here's a little bit of Paul Simon for you. I hope you like it. Take it easy, guys. Later.